This is the addendum for the vectors chapter. We're going to talk about vector product today. So on page 422, you can read about vector product. It happens to also be called cross product, which is easy to remember because the symbol for the operation it's like a big multiplication sign. In fact, this is one of the reasons why you should not use the third grade multiplication sign for advanced math, because it's used for cross product also. Scalar product from the previous unit has a result that is a scalar, and vector product has a result that is a vector. The vector product result is pointing in a direction that is perpendicular to the two vectors used to find it. Okay, so if you multiply two vectors together in a vector product, then you would end up with a third vector which happens to be pointing perpendicular to both of the vectors used to find it. Okay? And then here in this box, you're going to write down one of the methods used to find the vector product, and that might be writing it out in a table, in a matrix, and like the two, you would write the two vectors out across the second and the third row. And the top would be ijk, and then you would hide certain rows. Okay, so like the first row you're going to hide is the I row, and when you hide the I row, what you're left with is these four elements, and you are going to use these four elements to find the determinant, which would be A2 times B3 minus A3 times B2. And then you would multiply that times the unit I vector. The next thing you would do is you would hide this column, and then you would multiply the remaining elements, A1, A3, B1, B3, in determinant. So you would do A1 times B3 minus B1 times A3, and multiply that times the unit vector J. And then the last component you would do by hiding this row, and then you would find the determinant of A1, A2, B1, B2, which would be A1 times B2 minus A2, B1. And the reason why I'm not writing it all out is because we did this in the investigation, and I want you to just write the best way that you think is the best way. And then the other way would be you repeat the elements twice, B1, B2, B3, B1, B2, B3, and then you do multiplications diagonally, and then you do multiplications diagonally the opposite way, and you add and subtract those according to the investigation also. So either one of those methods, whichever method you prefer, or if you have another method, go ahead and write that down. Remember that the vector product formula is in the formula sheet, so you don't need to have a method like this, but you're going to do a few problems with vector product, and so probably you're going to figure out what your favorite method is, and you're not just going to use the formula sheet, especially because in physics you're going to use it a lot also. A cross product B is a vector which is perpendicular to both vector A and vector B. Cross product of A and A equals 0 for all A. Actually, it's the 0 vector. A cross product B is equal to negative B cross product A for all A and B. This means that A cross B and B cross A have the same length, but opposite directions. A dot B cross C is called scalar triple product. Scalar triple product. A cross product quantity B plus C is equal to A cross B plus A cross C. And A plus B cross C plus D is equal to A cross C plus A cross D plus B cross C plus B cross D. Okay. Number 1 from page 425. A. We're going to do the cross product of these two vectors. Okay. So I'm going to use the matrix determinant method. So I'm going to take the determinant of I, J, K, 2, negative 3, 1, and 1, 4, negative 2. Okay. First thing I'm going to do is I'm going to cover up the first column, and I am going to use the remaining numbers to do a determinant, which would be negative 3 times negative 2 minus 1 times 4 times the I unit vector. And then now we're going to do the same thing, except now we're going to cover up this column here. And so we're going to have the remaining numbers create a determinant 2 times negative 2 minus 1 times 1. And remember that for the second element, you use a negative sign here. And then the last one, we're going to cover up the K column, and then we're going to generate the K element. So it will be 2 times positive 4 minus a negative 3 times 1, and that would be multiplied times the K unit vector. Okay, so let's simplify these. The first one is going to be negative 3 times negative 2, which is positive 6, minus 4. 6 minus 4 is 2, so the first element is 2i. The second element would be negative 2 times 2, which is negative 4, minus 1, which would be negative 5. Then we take the negative of that, and we get plus 5j. And the last element would be 2 times 4, which is 8, minus a negative 3, which is plus 3, so it would be 11k. So that is the answer for part A. Part B, they give it to us in unit vector form, and so I think that it's a little easier to look at it in component vector form, so I would just immediately change it to component vector form. So it would be this cross I would be 1, K would be negative 1, and there's no J unit vector, so that means the J component would be 0. And so let's put this into our matrix and find the determinant. So 1, 1, negative 2, 1, 0, negative 1. First thing we're going to do is we're going to cover this up. So we're going to take the determinant of the remaining numbers. So 1 times negative 1 minus 0 times negative 2 would be negative 1, right? So that would be negative 1 times the vector I, a unit vector I. Then we would do minus the next element. The next element is found by covering up the J vector. And here we're going to see that the remaining numbers 1, negative 2, 1, negative 1 would be a determinant of 1 times negative 1, which is negative 1, minus a negative 2, which would be plus 2. So that would be positive 1. But remember, the second element is subtracted, so it also turns out to be negative 1. And then last of all, we're going to cover up the K column. And then the determinant here would be 1 times 0 minus 1 times 1, which would be negative 1 also. And so the last one would be negative 1 unit vector K. So basically it's negative 1, negative 1, negative 1. Okay? All right, and next page, next video.